thank you for coming to this parallel session. It's about one of the most important impact. It's agriculture and food. And I do hope we can keep it on time because this session is standing between you and the lunch. So before we start, I would like to give a very short introduction on SRM impact. So when I look at the literature and I find the first impact, the paper published, is on 2002. It's from Bala, and looking at how geoengineered world will change terrestrial vegetation. And in that paper, he pointed out already the decoupling of temperature and CO2, and that might have a dramatic impact on terrestrial vegetation. And then later on, in the year 2008, Dr. Alan Roebuck, they simulated the first time with SO2 injection to simulate sulfate aerosol injection, sulfate aerosol geoengineering. And in that one, they pointed out the precipitation change over Asia, the monsoon, probably will have a damage on agriculture. So those are in the discussion. So start from that, people started to think what would be the impact on agriculture if we do SRM. Very slowly, this whole area really evolved very slowly. And then the next paper really published, looking at agricultural impact, is in the year 2012. So it's Julia Pongratz using a statistic model and looking at global agriculture response under global warming and the geoengineered world. And then later on, I published a paper using dynamic crop model looking at agriculture response in China. Since when is the first time about agriculture, 2008, almost 20 years passed. Right now, we have probably less than 20 papers on agriculture impact. But which is extremely important and urgent, I think we need to really push through this area, have more effort to look at the agricultural impact, especially regional impact. So that's why I'm very happy to be here and moderate this session. We're going to hear 3 excellent speakers from different continents and looking at different crops and under different scenarios. So let's first welcome Temitope Egbebiyi. He is a researcher scientist in the University of Cape Town. He is one of the key persons in the South Africa team founded by DeGrace, looking at agriculture impact under SRM. So let's welcome him.
Thanks, Lili. Thanks for having me. Good morning, everybody. And thanks for coming for this session, which is a quite important one, as we look at the impact of SAI on agricultural production. Basically, we know that from the IPCC and different studies, we know what food security and having food on the table means for us as individuals. I know now that you've had breakfast, you are looking forward to lunch. Imagine if there's no food, we'll not be able to come together in this conference. So that's why we are looking at this important topic on crop suitability response to stratospheric aerosol injection in West Africa, and then probably speak to some other work that we've done in the other parts of Africa. Firstly, that's West Africa for you and some of the important crops that are important for the region. And agriculture is very, very important for us because it contributes to our livelihood as well as our economy. Livelihood in terms of having food to eat, and at the same time, economy in terms of it helps in the country's GDP and the region's GDP too. And each of the countries to have different crops that they depend on. Some of them are staple like maize, and all the crops that you can see there, they are very, very important for us in West Africa. And unfortunately, the region is one of the most vulnerable and hotspot regions that are suffered for significantly from climate change impact on food production, owing to the low adaptive capacity, as we know, in sub-Saharan Africa. And at the same time, So the crops that we are going to be looking at here, cereals and basically other two crops, cowpea and cassava, they are very, very important for us in the region. Like, for example, cereal contribute about 20% calorie consumption in West Africa, and then it accounts for about 4% of the African, of the region's economy. While cassava, the region, and then with Africa, contribute about 50% of what we have on the globe. So that tells us why these crops are very, very important, and then looking at the impact of how it will respond to SAI. And then with the projected warming from the World Bank report from some years ago that between 1.5 months will affect the agricultural sector by a reduction of up to 50% in crop yield, and it will affect up to 90% of the revenue in the region. That's one of the reasons why this is very, very important. Having said that, the aspect I'll be looking at it in terms of crop suitability, which speaks to how does a specific location meet requirement for growing condition of a given crop. And like I said, so this is just an example of some of the crops. Why do we need to look at crop stability response? One, because it's essential for agricultural planning. One, in terms of it helps us to identify adaptation strategies that we may need to look at in terms of our different crops that we grow, and at the same time to look at alternative locations where different crops can be grown in case climate change is ravaging that area too much. Then lastly, because of a increase in drought condition and decrease in the future rainfall, which are major threat to cropland suitability, as we've seen in different studies that may lead to crop failure. So that's why this is very, very important. Having said that, coming to geoengineering, which is not new to some of us, we had SRM 101 yesterday, so we all know the different forms of geoengineering, so I won't spend more time here. But basically, we want to look at how does SAI in particular will affect our different crops. And the reason for this is because, yes, it's been shown that it's going to help us to limit reduced temperature, but at the same time, our region is rain-fed. Some people have said that maybe it will affect rainfall. So it comes with its own accompanying impact as well. And studies have shown too that it's going to affect food security in some areas like West Africa, which are dependent on monsoon rainfall. So that's one reason why we want to look at these particular studies. Having said that, different studies have, another reason why this is important is that different studies have looked at different work in Africa, but most of the studies here too, they have looked at the main climate, which is very important to look at temperature, look at rainfall, and these are something from the African level to West Africa. Look at, Abiodun talk about how SPI will affect drought, and you know what that means in West Africa too, and then some other work that different people have done. So that's one reason why we are looking at this. So as a result of that, the research gap is there. We've looked at some crop suitability studies using climate change, but now there's a depth of information in terms of how SAI intervention will affect major crops in the region, and especially now looking at West Africa. So the aim of this work is to look at that. How will impact of global warming and SAI on main crop suitability in West Africa? And we use the GeoMIP data set, and then I'll show you another one that we did with maybe Glens. So these are the data set that we use, and the variables that we use, I'll talk about the model now, but we use the monthly minimum and mean temperature, then we look at the total monthly precipitation, and then we are looking at cereals. So this is very, very important for us, one of the staple crops. Look at maize, and then pear millet, as it's been shown, they are underutilized crops. And why maize is reducing with impact of climate change in the region, pear millet and sorghum has been shown that we can use them as a substitute for maize, both as staple and in terms of the nutritional value that we get from those crops. So that's one reason why you are looking there. Then we look at cowpea and cassava. Anybody from West Africa know the importance of cassava to the region. So that's the reason. And then the time period we look at, and then looking at it with, like I said, sulfur, and then with compare it with CMIP6. So the model we used, before we did that, we have to bias correct, because for impact study, the issue of bias correction is very, very important. And then the model we use is called EcoCrop, which was designed by FAO. And basically what the model does is to tell us about the optimum condition that will be suitable for a crop, where you can cultivate a crop at a time. That's one of the reasons. And like I said, the input into the model is, but we use temperature and rainfall basically because it's a rain-fed region. And then we use some suitability bands to show you looking at to be able to give us a spatial overview of how those different crops will respond to those particular climate conditions. And this is the eco-crop thresholds for the different crops that we use, the growing days, and then the So it's to show us basically where the areas where, the different thresholds for those different crops, as we see, that is what is the eco-crop used to generate the suitability, the spatial distribution map that we are going to see very soon. I think I won't dwell more on this because, like the other studies that I've shown you, have talked about how the models perform in terms of temperature and precipitation over the region, so I think I'll skip that because of time. Going to our first result, this is looking at series. So here it's showing us, So here it's showing us the spatial distribution in terms of crop suitability. I show you the bands that we used the other time. So wherever you see the brown, it's telling us the area that are not suitable. Where you see the belt of light brown is marginal. Then the light green is telling you areas that are suitable. And then this anything above 0.75 is telling us about the area that are highly suitable to cultivate those crops. And as you can see, that for these crops, most of them are highly suitable, especially if you look at the Guinea and the Sahel zones of the region, Guinea and the Savannah rather. And then you see areas that are marginally suitable around the Sahel, but anything above 14 degrees into the Sahel, you see that they are not suitable for the crops. So with SSP 245, we can see that reduction in maize in most part of the regions, and then maybe a bit of an increase now. This or that panel is showing you where we have increase in terms of where we can cultivate the crops. And then the same thing, but we look at the intervention of SAI, so that some areas will not change. That is, so this fourth panel is showing us that the difference between solar geoengineering intervention and then with SSP 245. You see that some area will slightly increase, some area there may not be any changes in terms of cultivating cereal crops with SSP 245. Then we look at the extreme scenario there with 585, where nobody wants to go there. We see that the response in terms of changes the magnitude increases, and then in terms of spatial extent. But we see that there may not be changes for some crops, while in some parts we have a bit of a slight increase with geoengineering under SSP 585. Then we look at it for cowpea as well, and under SSP 245, the same thing, we said similar pattern. The Guinea and the Savannah zones are very, very good in terms of cultivating the crop, but you see that in the Sahel, you see that those areas are not suitable. And then in terms of the changes, similar to what we see, no much changes in some parts. There's a few pockets of reduction in some part of along the coastal area in that area alone, but you see that we may have an increase in some part of the Sahel compared to what we have there, where this is marginalized. So maybe that area might move into suitable. And then you see this area for cowpea. This area is showing us that the marginal part now might become more suitable for those crops, so the marginal might move to become suitable. Then at the same time, we see it for under SSP 585, you see that the condition is not going to really improve much compared to what we have here for this. So that takes me to, then we try to now look at it in terms of the grid point and see what is the, what can we find there. You see that this shows us that for maize, with SAI intervention, you might be able to reduce area that are unsuitable. This is the blue one is showing you historical, and then the yellow, the different colors, the red for SSP 585, and then the green for sulfur. So that area that are unsuitable might reduce, and then area that become highly suitable may increase compared to what we have with SSP 245 and 585. That's for maize. And we notice something similar like that for pear millet as well, and at the same time for sorghum. So that tells us that SI intervention may improve series, suitable area, highly suitable area, by about 5% over the region, but may reduce some area, and the good thing is that it may reduce area that are unsuitable, so we may have better areas to cultivate the crops. Then we did the same thing for cowpea and cassava. We see for cowpea, you see a bit of reduction too in the area that are not suitable, but For cowpea, you see that the area that are not suitable, that are highly suitable, is not. We were able to get a bit more than SSP 245, but for 585, it doesn't show much. The same thing for cassava. And that's telling us that intervention may help us with in terms of relative to SSP 245 for cowpea, but for 585 it may not be. And for SA high, it improves cassava suitable area relative to SSP 245. And then with just to put it in perspective for other crops, we don't want to dwell only on cereals. The idea is to have, the SDG goal is to have healthy foods, healthy meals. So we are also looking at other crops too, like tomato, these horticultural crops that for your salads and all those things. So we are trying to look at that, and you see that this is just another study they are working on over the region, and you can see the message from here is that it may help us increase some areas for tomato and mango in some part of West and Central Africa, the same thing for here, but that might not be the same for what we see in orange in other parts of the region. So just to wrap up, the key findings here, we see that SCI intervention may lead to an increase in cereals for cereals, cowpea, and cassava in some parts, especially we see the size, there are some marginal area might become suitable. And then sulfur injection may lead to a decrease in cassava along the south coast, like I see for some other place in the Savannah and the Guinea. And then it may help us to increase the highly suitable area for cereals and cowpea as well in West Africa compared to what we saw with SSP 245. But we see that with cassava, it does not improve it with relative to SSP 245 and 585 in the region. And this is just the beginning. The next phase is to look at other data sets and now to show us how this region will respond to SA high before we begin to say, is it an area for us to grow in terms of what we are doing. Thank you so much.
So we probably have time. Let's do it immediate question 1 or 2, and later if we have time, then we will have all speakers up here and take more questions. So could you please? Thank you.
Yeah, thank Temitope. Yeah, please, can you explain well what you mean by suitable, non-suitable? Yeah, this is one question. And the second one is, analyzing glance and geomy simulation. Yeah, did you find some kind of disagreement between the different models somewhere?
Okay, thank you. So we're still going to use glance for the main one that I've presented, but the geomy pump, we've not done that for the last one. I just wanted to show you that we are looking at other things in parts of Africa that we're working on. And in terms of suitability distribution, so suitable is talking area where you can cultivate a crop per time based on the climatic condition. That's what I meant by the definition there. That is the climatic condition based on temperature and rainfall, because our agriculture is rain-fed. So, and that's why I show you the table about, so when we have a particular amount of rainfall, at the same time with temperature, the model, it's an FAO model, it shows that this area is optimal, you have an optimum condition to cultivate this crop at this particular time. So that's what we mean by suitable. So, and if it falls short of that, that means you are not able to cultivate that crop there. And you see, for that, we have some range of values. There are values that where you can't even cultivate anything at all. And there are some areas that the one you want to deal with is where you have optimum condition that will show you where that's why we classify based on areas that are not suitable and areas that are highly suitable to cultivate a crop at a time.
Okay, so if there's no question, oh.
Thank you so much for the presentation. It's very amazing and salient.
Thank you.
I have a question. So I want to know the parameters for the choice of the various staple foods that you chose, because top of mind, I'm looking at the major cash crops in Africa as the benchmark for this sort of research. I saw cassava in there, which is of course number 1. I didn't see coffee. I didn't see cocoa. Is there a particular reason for the choice of foods that you use?
Thank you. Good. The second speaker will speak to cocoa a bit. I've done a work over cocoa as well that was published 2 years ago, so the book chapter. So we've done something on cocoa. So We've done it for many crops, but at least just to pick some that I can speak to now, we've done it for yam. 90% of the yam globally comes from West Africa, so white yam. So we've done it for yam. So rice and wheat, but I just try to pick some of this one to relate. And the essence of picking them is, number one, maize is a staple crop, but we know maize is decreasing in the region. Then begin to look at the literature is going to underutilize crops that can replace the one that we likely depend on, and at the same time, we even have a high nutrition value for the region. So that's the rationale for choosing that crop. Yeah, coffee and cocoa, they are coming.
Thank you for your presentation. I think you are just taking, if you are doing impact study with crop modeling, you are just taking business as usual. So
okay.
We are doing, we are basing on green-fed agriculture. But my concern is if we can go beyond this. So why do not, or your crop modeling, if it's possible to integrate irrigation, so, and to see how SRM may mitigate the cost of irrigation. This also can go because we are doing impact study. The stakeholder need to hear about all those things. If we can avoid the cost of irrigation using SRM. So do not just keep business as usual, but go beyond this. Integrate irrigation and so on to see.
Yeah, we have that part with eco crops. So this is the first step. At least looking at it with rain-fed. So the other one is for us now to look at it with irrigation. So eco crop has that as well. So, but thanks so much.
So thank you, Jimmy. So yeah, there's a question about coffee and cocoa. And then let's move to our next speaker, Nina Grant. She is a PhD student at Rutgers University. She has been spent a lot of time looking at SRM impact on agriculture using agri-climatic indices and also dynamic crop model, which she's going to talk about. And so let's welcome Nina.
All right. Okay, let me get my timer so I can keep track of this. Okay. Hi, everyone. I guess we are just a little bit afternoon, so it's not good morning anymore. But yes, today I'm going to be speaking about what SAI, or stratospheric aerosol injections, could do to coffee and cocoa. And I will say a disclaimer, I'm going to be focusing on cocoa today, since that has the larger impact in Africa, and because I have not finished the coffee simulations yet. So if that was the reason that you came, I'm sorry, but you'll have to wait for the paper for the coffee results. All right, let's see how this is going. Perfect. All right, so why study coffee and cocoa? So this one I'm going to turn to you guys. Show of hands, who in the room likes chocolate? Yeah, okay. Who in the room drinks coffee semi-regularly? Yeah, so that's why. We're studying it because it's very popular and a lot of people feel very strongly about them. And even though, unfortunately, as much as we love these crops, they're actually only grown in very particular parts of the world. So both coffee and cocoa are tropical crops. And it's kind of been nicknamed the bean belt. So around the equator is where they are usually able to be grown. And the top 5 producers are Ivory Coast, Ghana, Indonesia, Ecuador, and Cameroon. And in fact, 70% of the world's cocoa comes just from West Africa, and 60% of that comes from just the Ivory Coast and Ghana together. So it has a big influence in West Africa for sure. So one of the things that makes tree crops different from things like rice and wheat is that there's a couple things, we're going to get into it, but it makes them particularly sensitive to climate change for a number of reasons. The first being that it's a real investment. So when you plant these trees, it takes 3 to 5 years before they even start to produce fruit. And they live for decades. They're usually most productive for about, say, maybe 7 to 20 years, but you can get fruit from them for 30 to 40 years, and they can live for as long as 200 years. There's been a report that a cocoa tree of 200 years old. And another thing that really makes these different from, again, your kind of annual crops like rice or wheat is that they age and they accumulate stress over the years. So they become less productive over time, aside from the stresses of climate change. And they can't bounce back the same. So if they experience a stressor in the year prior to that, something like a big drought, they're not as able to withstand the next, I don't know, heat wave or another series of droughts, or maybe it's heavy rainfall. Whereas if you have something like something that you're replanting every year, you can start over the next year. But these you'd have to wait. And for instance, if you have half of your plantation die from a disease, or again, something that's just an abiotic stressor, it takes another 3 to 5 years before you can get that back. So it makes them really susceptible to climate change. And just a small note for coffee, another thing is that the actual quality and the flavor that you get is dependent on the weather that it experiences. So climate change could lead to making it harder to find a good cup of coffee. All right, so current studies have estimated that rising temperatures plus a longer dry season will lead to reduced suitability in the region. And again, suitability is just this idea of, does the climate match what the plant likes? So is the temperature in its ideal condition, is the rainfall in its ideal condition? And these past studies have largely used the suitability concept, but it's not an actual crop model that simulates yield. So it's just looking at, do the conditions exist that the plant in theory could like, but it doesn't necessarily capture some of the interactions between those things, and it misses out the effect of CO2, which has been shown to improve the performance of crops, especially under heat and drought. So when the CO2 is high, it's actually better able to withstand really high temperatures or long periods without water. So what might happen under SAI then? So to look at this, we're looking at the ARISE SAI scenario, which uses SSP 245 as the background scenario, and the goal is to keep temperatures at 1.5 degrees above pre-industrial. This has been modeled by CSM, and in the past, studies have found that SAI leads to drying, a general global drying over monsoon regions in particular. However, the ARISE SAI scenario has shown to be less severe than some of those past experiments, and you can see here, at least again in CSM, over West Africa, SAI actually is able to more or less preserve rainfall in the region. So with that in mind, would high CO2 plus the same temperature about what we have today, and if it can maintain the rainfall that we have today, what would that mean for cocoa? So to look at this, we are looking at a location in southwestern Ghana, and we are using data from the EasyMIP initiative. They have a data portal online, and they provide data that has already been bias corrected and downscaled for the purpose of these types of impact studies. And so we were able to download 5 models right from their site, and for CSM, which did not have all the climate variables available at the time for EasyMIP to do it, we had one of our co-authors reproduce the method and create it for CSM as well. And something to note is that these models, we have one ensemble member for each. So that'll be important to consider when we look at the results, because the climate's chaotic, it's noisy. So you'll see it's not as clear a picture as it might be if we just looked at a model average. So to do this, we plugged this data from EasyMIP into a model called Almanac. And this is, it was invented probably, I think, in the 90s, and it was developed to simulate competition amongst crops, grasses, weeds. It can do a lot of things, but it in particular is able to capture competition for light, nutrients, and water. So this is also important for something like cocoa, where it's often grown in shade, so it can capture the interactions between the shade trees and the cocoa trees. It runs on a daily time step. It's site-based, which is why for right now we're just looking at this one location, and it uses a growing degree day system to model the growth of it, which just means how many days over a certain temperature are there. Yes, and it can also calculate stresses due to drought, flooding, temperature, nitrogen, and phosphorus. So it needs 6 different daily climate variables: minimum, maximum temperature, precipitation, relative humidity, 10-meter wind speeds, and incoming solar radiation. We feed that into the model, and it gives us yields and stress days. And now an important assumption that we make here to keep in mind, again, as we look at these results, is that we assume that the trees are permanently 10 years old. Wouldn't it be nice if we could just do that in real life, you know, just pick an age and stay there? But yeah, so we do this so that we can isolate what is from the climate and what is from just the trees aging, because the model also captures how the trees age, which is actually a contributing factor to why yields are so low in West Africa right now. There's a lot of plantations that are just getting older. All right, so let's get into the results. Keep in mind that these are hot off the press. Some of these answers might change, so don't go telling people just yet that SAI is going to do this and that to cocoa. Wait for the paper. All right, so let's explain what's going on here. So our blue, green, teal line, that's Arise SAI, as modeled by CESM. Our pink line is SSP 245, also modeled by CESM. This thick gray line is the average of our 6 different models, so that's CESM, UKSM, GFDL, all the models averaged together. The shading is the standard deviation, and if you can pick up the light gray lines in the back, those are the individual other models that we included. So what we see here is that under climate change, yields do decrease compared to our historical average. You also see this kind of declining trend, which again, we know is not the trees aging because we took that out. But you can also see the noise of the system. So what actually happens in real life is not this nice kind of linear path. And so we can see that CESM actually has an increase at the end. That could just be this one iteration of this one ensemble member of CESM happens to have better conditions at the end of the year than at the beginning. But we see that SAI, while it does still decrease compared to the historical, it's higher than what it would have been under SSP 245. So let's try to figure out why that might be. So hot days, days over 32 degrees have been shown to be damaging to cocoa. And we see here, again, the noise of the climate, all the different possibilities that could happen. But we see that generally speaking, this ensemble member is lower than our kind of model average of SSP 245, but you can also see that there's still plenty of years where it's right in the mix. So this also just goes to show that SAI won't necessarily eliminate hot days. We can still have some of those extremes, but generally speaking, we'll probably see less of them or less extremity in those high temperatures. So let's look at precipitation. So this agrees with what was found before, is that in West Africa at least, it doesn't seem that this version of SAI impacts rain too much. So it's basically still in line with all the other models. All right, and now that was just what the raw climate said. Now let's see what the crops actually experienced. So this is the output from the crop model that says how many days was the tree kind of like upset with what was going on outside. And stress days here just indicate when was the dominant and then therefore limiting stress, something like temperature or water. So it doesn't mean that temperature wasn't also bad that day, but water might have been the most important thing on that particular instance. So here we can see that Arise does reduce temperature stress, but we also see CSM is right next to it. So one thing we need to look into is that correct, or did we mess up something with the downscaling? But I think it could just be the result. And the other way you can interpret it is that the temperature stress days are low because water stress is very high. So you can see both for Arise and SSP 245, as modeled by CESM, that they are pretty much above, they're pretty much always above the average for the other models. So that's the other way to interpret that, is that water just ends up being more of the stressor than temperature here. And if we combine them to look at all the number of stress days, so that's water, temperature, nitrogen, phosphorus, and flooding, which those were very minor, temperature and water were the big ones, we can see that, again, SAI doesn't necessarily stand out as always better than SSP 245, but in general, it is beneath our average for SSP 245. But again, we see the noise here. So these, let's see, how do I do this pointer? Okay. Yeah, so we see, for example, 2051, 53, and 61. Those are drought years. And the timing of these things can impact the trees. Again, like I said, when a drought happens, it's not as able to withstand another stressor the next year. So This is just something interesting to keep in mind, that it's not this perfect, neat thing of SAI will do this and save the trees. It's a little more complicated. So what are the takeaways? What this is not saying is that SAI will inherently save cocoa or coffee from global warming. This is just one location. It's probably not representative of all of Ghana or all of West Africa. And it also, like we said, it's assuming that management isn't changing. So this assumes that we still kind of had this low input version of taking care of cocoa trees, and we are not letting the trees age. So in reality, those yields would actually be dropping a lot faster if the trees were able to age over time. And we also can't definitively say that SAI is, good or bad quite yet, because we need more ensemble members. So this is just one iteration of what SAI is. But it's important to remember that in the real world, we're not going to get the model average. We're going to get one of those crazy lines. And so it's important to remember that SAI might not look as neat and perfect as we think it will. But what this does say is at this one specific location, as simulated by this crop model and CESM, SAI does improve yields in Ghana compared to climate change without it. And this is because we're able to keep temperatures low, we're able to keep basically the same amount of rainfall, and now we have higher CO2. So there's a lot of next steps that we still need to do. Like I said, we're going to add more ensemble members to SAI so that we can find out more robustly what actually might happen as like a definitive effect of SAI and what's just kind of random. We also are going to rinse and repeat for coffee in Brazil, so stay tuned for that. And there's a lot more work that can be done here. I would love to add more ensemble members to the other SSP 245 scenarios as well, to simulate it over all of West Africa instead of this one location, but I am just one grad student, so if you guys want to hire me as a postdoc, there is a lot more work to be done. So thank you. If you want to collaborate, keep in touch.
Thank you, Nina. That's a great talk. So who raised hand first? Okay.
Great work and excellent presentation in the graphics. So we are looking for postdocs.
Okay, nice.
Or for experiments in the field.
Okay.
At such locations. So my question is, do you have like histograms of historical temperature at the daily scale? I'm just wondering like how much are the actual differences in temperature for the mean and maybe for extreme, and how does the extreme during the day actually influence the yield? If you just go 2 hours, say to 35 degrees or 40 degrees, like those flash droughts, are those in the model?
That is a good point. So for those who maybe didn't quite catch the question, it's about how, more or less the timing of some of these extreme events. So for example, there's a 2-hour heat event versus a 2-hour rainfall impact. Does that show up here? So this model runs on a daily time step, so it won't be able to catch those hourly kind of variations, but that is something that in real life does matter. So usually temperature isn't that time sensitive, so if it's only like an hour for like the hottest part of the day that technically goes over 32 degrees, you're probably not gonna get major results. It's more so if the daily average was above that, so most of the day it was outside of the plant's range. But we've also found a lot of studies show that as long as water requirements are met, usually plants can withstand temperature extremes a little bit better. But yeah, that is not something that the model will capture, like those kind of flash flood events. But it'll only capture the daily. So like today had a lot of rain versus yesterday, but it won't capture that. It's like, oh, all the rain fell within an hour, not over the whole day. So that's something that's not in the model.
Yeah, thanks, Nina, for your presentation. I would like to know your thoughts on this. So we know that water is the immediate threat to cocoa and coffee when they are growing in terms of flowering. And you did mention that with the same amount of water and a little bit of temperature change, then it's likely to be affected. The crop yield is likely to be affected. But then if you look through West Africa, our diurnal temperatures don't vary that much. So then what is your thought? Because you are making an assumption on the fact that there are changes in the diurnal temperature range and the same amount of water being retained by the crop or the plant. So what are your thoughts on that?
Sorry, can you repeat the, the question again?
No problem. You did mention that the diurnal cycle, the changes like I think 32 degrees max threshold, and I'm saying that in West Africa we have little variation in our diurnal cycle. However, we know that water is actually critical to these crops rather than temperature. And then you assumed that I think the same amount of water. There was an equation in your last slide where you did.
Oh, yeah.
Yes. So what are your thoughts on that?
Yeah, well, the model is capturing that effect. So we give it maximum and minimum temperature, so it can see the diurnal temperature range. And then the precipitation, it's calculating how, I don't know off the top of my head which one tends to be more stressful to it, whether it's temperature or water. But it's calculating those interactions. And so again, like if it's both are out of its range in one day, it's gonna figure out which one is most outside of its range that actually limits the yields. But it will capture that interaction. So the idea that the temperature, at least the hot temperatures, because I don't remember seeing too many studies talking about nighttime temperatures being a threat to cocoa, but at least the hot days have been one that's mentioned. So that was kind of just a reference to look at the raw climate data and see what's going on that might be influencing it. And then those stress days is actually what the model spit out as, oh yeah, this is what was stressing out the plant on these, this year and this, yeah.
Yeah, thanks for this presentation. Yeah, I would like to know if there is not some variable missing in your study, for example, the soil quality. If, for example, in Benin is not a producer of cocoa and coffee. So, can we explain why, for example, some of our regions are not suitable to produce cocoa in West Africa, and maybe in your variable, in your driver, maybe there is some of a variable to be included.
So you were saying that there might be some other variable that's more important than the ones listed? Is there like one that you've heard of that's particularly threatening to cocoa?
Yeah.
Yeah, because like, for example, I know pest and disease are another really big impact, and that's not something that the model is explicitly calculating, but we can add a damage factor due to pest. So right now, we have the rate at which today's cocoa yields are often threatened and reduced by pests, but that's something that will change in the future, and that's not being shown here. I am trying to think if there's any other variables I've heard of that could be at risk as well. But for example, another thing that will change under SAI is the type of sunlight that reaches the ground. So we get more diffuse radiation versus direct. We also might get more UV. And that's not something that's captured in this model, but we would need to consider under SAI if that has a significant impact. So yeah, like I said, there's a lot more that can be done here. But yeah, this is our first look at it.
I just want to expatiate this question with my own question. I think his question is that, does the model have the edaphic, the soil component? Like, for instance, models like DSAT, the soil component. So probably because of the edaphic factors in those places, the plants may not be able to not grow in those areas. So so the model does have soil properties in it. So